In this video, we will find compositional functions. We'll find f of g, g of f of f, g of g, and their domains. So, the first composition we want to find is f of g. And this can also be written as f of g of x. So, the key here, the first function that you see from left to right, whatever that first letter is, that should be the first function that you write down. So, first function that we're writing down is f of x is equal to x squared. The function that you see second is the one that's going to get substituted in. So to help us to remember that we are using a composition, we're substituting in a value for x, what we're going to do is to rewrite the problem and just remove the parentheses, remove the x in the problem and leave an open set of parentheses. So this is a reminder that we're actually plugging something in. If you look at this notation, it's easy to see that g of x is what's going inside the parentheses. So inside the parentheses, we put the other function, x minus 3, the square root of x minus 3. On the left-hand side is just regular notation. It's just telling you that we substituted in x square root of x minus 3. On the right-hand side is where we simplify. So the square root of x minus 3 squared, the exponent of 2 cancels out our radical sign, so we're left with just x minus 3. So if we want to know the domain of this, whenever you're working with your composition of functions, you have to pay attention to the value that you're actually plugging in. So what are you substituting in? You have to pay attention to that domain and pay attention to the domain of your result. So here we substituted in g of x. So whenever you're working with radicals and you're trying to find the domain, you always want to make sure that your radicands, whatever is under your radical sign, is greater than or equal to 0. We only want 0 or positive numbers under our radical sign. So solving this, we have x is greater than or equal to 3, and our interval notation is 3 with a bracket, and it's a bracket because it's equal to 3 as well, and positive infinity. If we compare that with the domain of our result, this is a linear function. And the domain of linear functions is negative infinity to positive infinity. So our domain is only what works for both, for what we substituted in and our final result. So our domain here is from 3 to positive infinity. That's the only thing that works for both negative infinity to positive infinity and 3 to positive infinity. Next, we want to find g of f. So g is on the outside. So that's going to be the function we write down first. And we put an open set of parentheses to remind ourselves that we are taking x out and we're replacing it with our other function. And what you're replacing it with is whatever comes second, f of x. So inside of our parentheses, we are plugging in the value of x squared. So our composition of functions is the square root of x squared minus 3. You can't simplify this any further because this is the square root of this entire expression. So when you find your domain, once again, we're paying attention to what we plug in. We substituted in f of x. The domain of f of x is negative infinity to positive infinity because it's a polynomial. It's quadratic. We have to also pay attention to the domain of our result. So since it's radical, just like we did before, whatever's under your radical sign has to be greater than or equal to 0. So we take x squared minus 3 and set that greater than or equal to 0. So we have to remember from our section 1.6 how to solve quadratic inequalities. The first thing we have to do is to find the zeros, our solutions, our roots. Where is x squared minus 3 going to cross the x-axis? So we have x squared is equal to 3. X is equal to plus or minus the square root of 3. So the second part in solving x squared minus 3 is greater than or equal to 0 is to perform our sign test. And with the sign test on our number line, you put your zeros, your solutions, your roots. Then you test a value in each of these regions to see what really gives you values that are greater than or equal to 0. So you would have to plug in the square root of 3 in your calculator, and you'll see that the square root of 3 is about 1.7. So if I want to test a value in this section, we can test -2. So we take -2, plug that into our inequality. -2 squared is 4. 4 minus 3 is 1. And 1 is greater than 0. So yes, everything on the left of -3 gives you values that are greater than or equal to 0. Next, we need to test our second region in between negative square root of 3 and positive square root of 3. So we can test 0. So if we plug in 0, 0 squared minus 3 is greater than or equal to 0. -3 is greater than or equal to 0. That's not true. So the second section is not included. Then we need to test our third region, something to the right of the square root of 3. So since the square root of 3 is about 1.7, we can test the value of 2. So if we test 2, 2 squared minus 3 is greater than or equal to 0. 4 minus 3 is greater than or equal to 0. So 1 is greater than or equal to 0. So this section as well produces values that are greater than or equal to 0. So our domain for g of f is this section of our number line and this section of our number line. So our domain is -infinity to negative square root of 3 union square root of 3 to positive infinity.
Made with Doodlecast Pro.